197. Now it says we're going to be adding and subtracting fractions. We've already been doing that. It says we're going to do it with unlike denominators, and we've already been doing that. But now they kind of throw a curveball at you. What do you notice? What do you notice about all this stuff?
It's got an equal sign in the middle.
Okay, it's got an equal sign.
Let all have even numerators, and they all have different denominators.
Okay, they all have different denominators. What else?
Oh, and three of them. The threes are beside each other.
Okay.
And then there's two numbers also beside the threes.
Okay, there's a 3 in each of them, and with another number. Anything else? What do you notice about these two?
They can both be even.
Are they equivalent?
Yes.
Okay, but these aren't, are they?
No.
Is 3/6 equivalent to 2/3? Those aren't equivalent, are they?
No, that's not.
So we know that this can't be equal unless we put something else in here. So let's see if we can figure out what we need to put in there. First of all, we need to work each side, don't we? We have all the parts for this side, so we'll work it first. We know that this side is 2/3 plus 3/5. And we know if we're adding fractions, they need a what?
Common denominator.
Okay. What will 3 and 15 both go into?
15.
15.
You said Chloe 3 and 15 both go.
3 and 5 both go into 15. All right, now can I just bring these numerators on over?
No.
No, I got new denominators, so I have to have new numerators. We ready over there? All right. What would I have to do to 5 to get 15? So I have to do it to this also. And my new one is?
9.
What would I have to do to 3 to get 15? So I have to do it to this one. So this new numerator is?
10.
All right. Now what do I do with my denominator?
Nothing. Bring it down.
Bring it down or keep it. That's why we got it in common. All right. 10 plus 9.
19.
Now.
4, 15.
Okay, so 15 goes into 19 one whole time with how many left over? 4, and we were dealing in 15. So now we know that this side is 1 and 4/15. Well, we have to make it equivalent to this side. So let's see what we have over here. And then we don't know. But if I work this, they do have to have a common denominator.
60.
Okay? Since we don't know this one, we're going to have to go with what we would get here.
18.
Now, what did I have to do to this to get this?
Times 10. And that one times 6. It's a half. 36. You can do. What else? I don't know. 66.
Let's see if we can simplify this. Okay, let's see if we can simplify this.
Well, I do know one thing. We'll have 4.
This is divisible by what?
10.
So,
30. 115.
so we would get
4, 6. Wait, what? That's your business. 5, 6.
Let's think about something for a minute. Will Is there a lower number I could have used here?
You can use 15.
Yeah, you get divided by 2.
I could divide by 2, and then I would have
15.
over,
30.
and then I would have,
Oh, you can divide it by
18.
18. You divide it by 2.
by 12.
Yeah, 12.
and I would get,
3.
and then I would get,
5.
10,
No.
but I have to have these in the same. So
it'll be,
what would I need to divide them by? Because I got to get this. This has got to be a 30.
36 divided by 6 is 6. So 15. Yeah.
What did I do to have to get a 30 here?
Divide by 3.
So I got to divide this by 2. And how many is that?
18.
18.
I already said it.
I'm sorry, baby. I didn't hear you.
He did say
Okay. So we're still a little off here. So I know I would have to bring this down, wouldn't I? And what do I get if I add 15 and 18?
that. 15 and 18, 33.
Okay. Can I reduce that? Okay, it goes what? How many whole times?
1.
How many left over?
3 30s.
So does this work?
No.
That doesn't work, does it? Let's back up and think about something. Let's think about something. All of these numbers, just these numbers, what's the lowest number they would all go into? So let's look at 3 times 1 would be
3.
3. 3 times 2 would be
6.
3 times 3 would be
9.
3 times 4 would be
15, 18, 21, 24, 27, 30, 33, 36.
all right, we're out of room. Let's stop right there a minute. Let's do by 5s. 5 times 1 is
10, 15, 20, 25, 30, 35, 40.
let's stop right there.
Oh, me.
What about the 6?
6, 12, 18, 24, 30, 36, 42.
Let's stop right there. What about the 10s?
10, 20, 30, 10, 20, 30, 40.
Let's stop right there. What number do they all have in common?
30.
So what's a common denominator for everything that we have up here?
30.
So let's go back and work this side as 30. Since we now know that that's a common denominator for everything. Okay, so now that we know 30 is a common denominator for all of it, let's just use 30 for everything. What would I have to do to 5 to get 30? So I would have to do it here also. So my new numerator. Okay, what would I have to do to that to get 30? Okay, so I'd have to do it here. So my new numerator. And I keep that denominator. That's why we got it in common. And then what do I have?
Add, that's 38.
Okay.
So you got 8
Now, let's move to this side. We have 3 6, 6/10, and we don't know.
Okay.
But if we know that we're going to have to use what number? 30, because that is a common denominator of everything we had. What would I have to do to 10 to get 30? So I have to do this, and I would get?
18.
What would I have to do to 6 to get 30?
Times 5.
So I would have to do it to this, and I get? Now, how much do I have already right here?
33 30s.
Oh, that's
I have 33. I'm trying to get it equivalent to that. So how many more would I need right here?
5.
I would need 5, and then that would give me 38 30ths, which is the same as 1 and 8 30ths. And if we simplify this one, we get 1 and
4 15. Wow, look at that.
and if we simplify this one, we get. So what number made this equivalent? 5 30ths. So when they give you one, and they're asking you if several different things are equivalent, if you can't think of a common denominator, take all of your denominators, skip count with them for a ways. See when they have something that matches up. That's your common denominator. A long time. And unfortunately, some of them on the ACT Aspire are going to take you a long time. All right, next page. Tyler says to find the sum, I can use 18 as a common denominator. Hans says to find the sum, I can use 24 as a common denominator. Claire says to find the sum, I can use 48 as a common denominator. Who do you agree with?
I'm thinking Claire.
I'm going with Han and Claire.
Okay.
Not
Okay, we hear a lot of people saying Claire. 48. Will 6 go into 48 evenly?
Yes.
Will 8?
Yes.
So that works, doesn't it?
But they can also go.
Will 6 go into 24 evenly?
Yes.
Will 8?
Yes.
So Claire and Han are both correct, aren't they? But will they both go into 18? No, only the 6 will. So Tyler's not right. Now, what's going to be the only difference in what Claire and Han do?
They'll have to simplify.
Claire will have to simplify one more time, won't she?
That's not a big deal.
24
Yeah, that's why I won't.
So now it says, what is the value?
Well, heck. So if we use 24, that's 2
So if we use what Han said what? 24. Okay, what would I have to do to 8 to get 24?
Times 3.
Okay, so I have to do that here in my new numerator.
15.
What would I have to do to 6 to get 24?
Times 4.
So I have to do that here as well.
16.
Then I keep that denominator. That's why we got it in common. 16 plus 15.
31.
Okay. How many whole times?
1
How many left over?
7.
Yeah. 24.
Okay. So that's using Han's method. Now let's use Claire's method. We still have start off with the same ones. But Claire said we were going to use what?
48.
Okay, what would I have to do to 8 to get 48?
Times 6.
Okay, so I'd have to do that here in my new numerator.
30.
What would I have to do to 6 to get 48? So I would have to do that here also. What's my new numerator? I keep that denominator, that's why we got it in common. And then I add my numerators. What have I got?
62.
How many whole times will 48 go into 62?
One.
With how many left over?
14.
Out of what?
48.
If I divide these both by 2,
You would got.
You would've got 7.
You mean
That's
Claire?
7.
I would get 1 and...
7 and 24. 7 and 24.
Okay, so did we get the same thing?
Yep.
Yes, we only had to do what we said from the beginning. Claire had to simplify one more time.
Yeah. Pardon me.
We only got one more page.
Lord, y'all don't get the hang of it when we do 15 pages. Y'all gonna get the hang of it in one page.
Yes. Yeah, I wonder. It's better.
All right, unlike denominators. Now, this time, we have 2/5 and 13/15. So what's our common denominator?
30.
No.
I heard it from the back.
15.
15. Okay. Put the cubes up, please. Would I have to change this one? No, because I would just be multiplying times 1 and I'd still get the same thing. Now, some of you are still doing that. You're just, even, some of you are still bringing just whatever you had over there, over here.
That's 6.
Can't do that. If you get a new denominator, you have to get a new numerator. All right, so what would I be doing here?
Times 3.
Okay, so I have to do it here.
6.
All right, then I keep that common.
19.
4, 15.
All right, it goes one whole time with how many left over?
4, 15.
Can I simplify that?
Yes.
By what? 15 is 15 divisible by 2?
No.
Okay, are either of them divisible by 3?
No.
4?
No.
So since this is not divisible by this, we are in simplest form.
I wonder how simple can you get?
Really simple.
All right, now pay attention on test, please, because it's going to have the answer you would get if you added. But it didn't say we're adding, it says we're subtracting. But do they still need a common denominator? Yes, and what's it going to be? 15. Okay, am I going to be able to just slide anything over on this one? No, because I got new denominators for both of them, so they both have to have new numerators. What would I have to do to 3 to get 15?
Times 5.
So I have to do that here.
That's 5.
What would I have to do to 5 to get 15?
Times 3.
So I would have to do that here.
18. That's 18.
Now I keep the denominator whether I'm adding or subtracting. And then 18 minus 5,
13.
is that in simplest form?
Yes.
Yes. What kind of number is 13? What kind of number besides an odd number? It's a prime number because it doesn't have any factors except for 1 in itself. What about 15? Prime or composite? It's composite because it has other factors. All right, now they're throwing a mixed number in with us. When we all go at 9:15. All right. They still have to have a common denominator. Now, I said if you can't think of one in your just using your multiplication facts, write out their multiples for a minute. 12 times 1 is?
12.
2 is?
24.
3 is?
36.
And if you know your math facts, that should have stopped you right there because 9, then
18. 27.
Ooh, look at there. So what's our common denominator?
Yes.
I still have my 3, don't I?
Times 4.
Okay, so what would I do to 9 to get this? Okay, so I would have to do it to this. There's too much talking. What would I have to do to 12 to get this?
Times 3.
So I would have to do it here also.
93.
Then I keep my common denominator, and for now I keep my whole number.
33 plus 20 is 53.
Okay, now, this one gets a little tricky on us. 36 will go into 53 how many whole times?
1.
It'll go once, so that'll give me one more whole one, won't it? So now I have 4 whole ones. How much would be left over? 17 what?
36.
No.
Is it in simplest form?
Yes.
Yes, because 17 is a prime number.
I think we're going to
We're still not done. One more.
I think we're going to get rid of this.
All right, last one. We have 6/10 minus 9/25. Now, if you can't see it immediately, go to the side and skip count. We have 10,
50. That's it. 60.
and then we know 25 will go into 50, won't it?
40.
All right. What would I have to do to 25 to get 50? Okay, so I have to do it here.
18.
What would I have to do to 10 to get 50?
Times 5.
So I have to do it here.
30.
I'm subtracting, so I keep my common denominator. Good.
30 subtract 8. 40 days.
Okay. Can't do this, can I?
28.
So I'm going to have to borrow.
That's 28.
All right, now 10 minus 8.
2.
2 minus 1.
Okay. Yeah, 2 minus 1 is 1. 2. 1.
Is this in simplest form?
No. You can divide by 2. Yeah, you can divide by 2. You can divide by 3. No.
There is nothing to borrow a whole 50 from.
Yeah, we weren't dealing with the whole number on this one. We were just dealing with our numerators. Is it in simplest form?
Divide by 2.
They're both divisible by 2.
It's 25.
Is this in simplest form?
Yes.
Yes, because there's not a number that 6 and 25 will both go into with no remainder. So what kind of number is 6?
Composite.
Composite. What about 25?
Composite.
Composite. All right. Is that the last one? That is the last one. Peace.